Alright, so in the last screencast we were talking about error handling for RCPP interface functions, and so I think we've covered pretty much all of the bases about how to interface C++ code with RCPP in an R package. The next thing I wanted to discuss is how to port this algorithm that we've implemented in Eigen template library code to Armadillo template library code. So when you look at our implementation of predict one to max neighbors, it's using these eigen map, eigen matrix XD, eigen vector XD guys, and these data structures are defined by this include eigen dense template library. And so this is one C++ library that's for doing linear algebra operations, and another one that's relatively well supported in R is called the Armadillo package. And so to do that, I mean, there's this whole RCPP Armadillo package, which is for doing this, and so it's just another way of doing it. And so I figured that I'd show you a second way of doing this. So so let's try to take a look at one of these examples. So maybe not the best example to get started with, right? So I mean, what I'm looking for here is let's just look at the main package page. There we go. So yeah, this is pretty much what we want. So we want to have include RCPP armadillo.h at the top instead of having to include eigen. And then, you know, basically what we get is, well, in this description, they're actually accepting these things as arguments in the, you know, in this RCPP code. So here you see the RCPP declarations, but here my intended usage is to use these ARMA data structures here. ARMA callvic is what they're using here. ARMA square root, ARMA diagvic, all this kind of stuff. You know, I'm going to be using this inside of my C++ subroutine. So let me just copy this line of code. I guess let's do that. And so let's do, yeah, so it's going to be here. Put that there and get rid of that eigen dense call. And so, yeah, I mean, there's only a couple things that you really need to know for implementing this. Is that right? So, yeah, so in fact, you know, we can look at the Armadillo documentation, and there are just basically three things that we need to look up. So that's not the right link. We can, you know, number one, what we need to do is we need to figure out how to convert pointers into Armadillo data structures. And so basically we need a constructor, you know. So here this is what we want. There's these advanced constructors. The first one is pretty much exactly what we want, creating a matrix using data from a writable auxiliary memory where pointer is a pointer to the memory. So so that I think is the first kind of tool that we need. So let's do that. So the first thing is when we're reporting this code, you know, we just have to look down. So that's essentially what this eigen map thing is doing, right? So instead of having this eigenmap thing, what we can do is we can use this ARMA mat, and we'll call this by the same name, train inputs mat, and this thing is going to be taking as input train inputs pointer, and then end row and end call are going to be those things. Copy the memory. Let's do false there to avoid the overhead of copying. And strict, what does that mean, strict? It says when it's true, the matrix will be bound to the auxiliary memory for its lifetime. The number of elements in the matrix can't be changed. So yeah, let's make that true as well, because all we want is basically like a light, you know, kind of a lightweight, user-friendly access to that underlying memory, the trained inputs pointer. So if we, you know, do the same thing for this next line, what would it look like? Arma mat test input vec test input pointer and call. Is that right? So yeah, for, I wonder if we have another one for vectors. So yeah, here we go. So create a column vector using data from, so same kind of thing, right? So instead of arma map, we have an arma vec, test input vec, test input. So it's the same kind of thing. Copy auxmin is true, it's strict equals false, right? So the only difference is we have, so here we don't give named arguments in C++. So, but we do have, but we will have false and true there. So let's see if that works. Then after that, you know, the next part of, so all we did there is we're just creating this matrix and this vector data structure on top of a double pointer, and so that's just going to give us fancy methods for accessing that later. So then the next thing that we need to do is, here I'm doing a for loop over all of the observations in the training data set, and we're computing the distance, the L2 norm distance from that train data point to the test data point at every iteration. So to translate that code, all we need to do is we need to figure out how to access the different rows of the training data. So let's see about that. We should have some documentation at the top here. So element access, fill, I think we want, do they have a .call method? Yeah, I think that's what we want, .row. Right, so if A is a matrix and then we use a .row, we get the row vector there. So let's see if that works. Same thing, actually. Same syntax as that we were using in Eigen. Do they have the .transpose method? Maybe not. .t, right? So transpose copy of the matrix. So there, let's do a .t. We subtract away test input vec, which is a column vector. and then we take the norm, and I believe they also have a norm function which is defined. Let's see about that. Is that right? Yeah, norm. So I guess it's not a it's not a method, but it's a function, right? So norm of x. So let's change that. So instead of putting norm as a method, let's have norm of that guy. That more closely, yeah, it's just a different syntax. And so here, before what we were doing is we were having this sorted index pointer. And so what is this thing? So we were using standard sort to sort all of those indices. There's actually a different way of doing the sorting in there's a convenience method for convenience function for doing the sorting in Arma, but we're not going to talk about that right now because this code should work. So let's instead let's try to do let's try to just eliminate all the other eigen calls. So looking down, we have, I don't think we have any more specific eigen code over here. All we were using eigen for there is for computing the distance, the L2 norm. So are we using eigen at all in the second one? Let's see. So yeah, we are using eigen in the second one. Again, we're using eigen maps and eigen vector xd. So here we're using it basically for dynamic memory allocation. So in this case, yeah, so in this case with the eigenmap, we're just using it as an interface to easily access different rows or columns of this matrix, right? So here we're extracting a column of of that guy, and so let's take a look at first porting that. So again, what we want to do is we use the same syntax that we used above, so I'm just going to copy that. And so yeah, I mean, here this is going to be test inputs mat, test inputs pointer, and it's going to be ncall and test, and then false true again. Here, let's do the same thing for this guy. Comment region. That's right. Yeah, so this one, it's going to be test predictions pointer with max neighbors and test false true. And so yeah, then we have to look down here, change this guy to, let's look at our code for Arma vec again. Arma, sorry, this vec, that's, sorry, I'm getting lost now. Yeah, there it is. So these are the two things that we want to get rid of. We're going to replace it with distance vec, in train. This is going to be sorted index vec in train. And then after that, we just have to look at how we're using these things down below. So it looks like we're just using a lot of these data calls to get access to the pointers. So, then we just have to look out what is the, there was that argument call pointer, right? Mem pointer. Maybe that's what we want, right? So, obtain a raw pointer to the memory used for storing elements. So, that's what we want. So, call a pointer. So obtain a raw pointer to the memory used by the specified column. And so that's exactly what we want too. So instead of having call something data, let's just have call pointer test I, call pointer test I. And then after that, we can just have pointer, right? So that'll be, mem pointer, that's right, mem pointer. So let's see, I think that's all the references that we have to Eigen in our code. So let's try recompiling and see what happens. It'd be great if that worked the first time, but let's see, we got some error. So it says rcpp armadillo.h, no such file or directory. Okay, that's understandable. So let's fix that by going to the description. rcpp armadillo in the linking to, that should fix that if we have that installed. Let's see. That's not working. Dependency rcpp armadillo is not available. So let's install it. Install packages rcpp armadillo. And so there may be a little bit of compilation that we need to do to install that library. So I will resume in the next screencast once that is done compiling.